Welcome to your equivalent fractions tutorial. So when talking about fractions, children need to understand that a fraction is a part of a whole. So for example, here we have a whole split into eighths. So we know that when they match, it is equal to, it's equivalent to a whole. For example, again, a whole from thirds, and here out of fifths. These are all equivalent to one whole because the numerator, the top number, matches the denominator, the bottom number. So these are all the same as a whole. Our key vocab here, whole, parts, equal to, represent the same. So these all represent the same amount. When talking about fractions, we can also use a fraction wall. We've got a fraction wall just here. Here is our whole. Here we've got 1, 2, 3, 4, 5. So we can say that this part is made out of fifths. So if every single one was shaded, we'd have 5 out of 5, which would be a whole. But each part represents 1/5. Along like this. And below it, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know our denominator, our bottom number, is worth 10. I am going to shade 4 parts, 4 equal parts. So I've got 5, I've got 4 over 10. Looking at my fifths, I'm going to shade 1 part. And then I'm going to shade a second part. So they are equivalent fractions now. So I can say that 2/5 is equivalent, is the same as 4/10. They are equivalent fractions. They represent the same amount of a whole. Here we have 2 shapes. We've been split them into 4. 1, 2, 3, 4. I'm just going to shade this part and I'm going to shade this part. I have shaded 2 quarters. I could do the same here. I've also shaded 2 quarters. Sometimes questions will look like this and children can find that a little bit difficult because they are not next to each other, but they are still the same amount. We can also use fractions when talking about real life items. So here I've got a Kit Kat, an orange, a pizza, and a glass of water. I've got a whole bar of chocolate here, a whole Kit Kat. It has been split into 4s. It's been split into 4 parts. Therefore, we are working with quarters. If I ate 1 piece of the Kit Kat, I could say I'm eating 1/4. With the orange, it has been split into 2 parts. It's been split into half. I could say the orange, that piece is half, and that piece is half. With the pizza, I've got 1, 2, 3, 4, 5, 6, 7, 8. Each part is worth 1/8. With this question, it's quite common to see things like, I have 8 friends over and we are sharing a pizza. How much would each friend get? We'd say they'd get 1/8. This one, a glass of water, it's been filled with water up to halfway. 1/2. Looking at equivalent fractions, we could say if I ate 2 pieces of chocolate here, like that, 2 quarters, so 1/4 plus 1/4 equals 1/2. Okay, so 2 quarters is equivalent to 1/2. Same with the pizza here. If I ate half the pizza, I would be eating 4/8. So children need to get really used to seeing equivalent fractions like this, 4/8. We can also see that 4/8 is equivalent to 5/10. They are both represent the same fractional amount of 1/2. Children will often see questions in papers such as this one. They can see here that for this first question, they are looking for equivalent fractions and there is a space missing. In this side, we have 1/7. Children need to work out what would go in this box. So they can use their times table knowledge and they can see this one here has been times by 2. With fractions, whatever you do to the bottom number, you must all do to the top number and vice versa. So you can do the same to this top number. 7 times 2 is 14. We've worked that out already. 1 times 2 is 2. Therefore, 1/7 is equivalent to 2/14. I'll do another one here. This top number, once again, is being times by 2. Whatever we do to the bottom, we must do to the top. That's times by 2. Therefore, 3/4 is equivalent to 6/8. This one here, working backwards, we can see here is 2. What does 2 need to be times by to get to 10? It needs to be times by 5. Whatever we do to the bottom, that way would be times by 5. So now we need to work backwards and we would divide by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. And there we go. Equivalent fractions.